In this video, I want to walk you through analyzing the potassium nitrate thermodynamics data that we'll get in the lab using Excel. Excel is by far the easiest way to, or some other equivalent program, is the easiest way to analyze this data. So I have created a Microsoft Excel worksheet that should look similar to the back of the data that we're collecting in the lab. I have gone through and, quite frankly, I've made up precipitation temperature data. I also made up milliliters of solution. Okay, so please don't read anything into these numbers. And the mass of potassium nitrate, which was similar to what we used in the lab. So I'm going to take you relatively quickly through how you would use Excel to do all of the calculations for you to analyze this lab. The first thing is we want to calculate the molar concentration. So we want to take the mass of potassium nitrate. So to do that, I'm going to hit equals and select that block. And then we want to divide by its molar mass, which is 101.1. And we're also going to divide by the volume in milliliters, but we need to change that milliliters into liters. Okay, so once we have that, we could hit enter and Excel calculates the molar concentration for us. Then if we didn't want to type that in anymore, we can grab hold of this little square at the bottom right hand corner and drag that formula across, and it updates to calculate the relevant concentration for everything. Okay, so now we've got the molar concentration. The next step is to calculate the KSP. So the KSP is going to be the square of the concentration. So I'm going to say equals, we'll select the square above it, and then we want to square that thing. Hit enter to lock it in, select it, take the little drag corner, and drag it on across. So that's our KSP as a function of temperature. To collect the natural log, we're going to do equal natural log, and then we select this square above it, close parentheses, enter, there we go, and we're just going to drag it on across to calculate everything. Temperature in Kelvin, we want to say equals, and then we'll go up and we'll select the temperature above, which was in degrees C, and we're going to add 273.15 to it. Hit enter and drag across. 1 over temperature, taking the inverse of that, we want the inverse of the temperature in Kelvin, so we'll do 1 divided by the temperature above it. Hit enter and drag on across. Now delta G0, we have to use the formula that delta G0 is equal to negative R times T times the natural log of K. All right, so we're going to hit equals R, which is 8.314, times the temperature. So we select the temperature box, times the natural log of K, which is the box above it. That looks good, except we forgot a negative sign. It is negative RT ln of K. All right, so we went up top and fixed that, and then we'll just drag it across. Right? So now we have delta G values. The analysis of the lab wants us to make a plot, and from that plot, pick out the slope and the intercept of a best fit line. I'm going to show you how to do that without making a plot first, and then I'll go ahead and show you how to make the plot just so we can make sure our data looks good and there's nothing really wonky about it. So if we want to just calculate the slope given a set of x and y data, Excel can do that. So we can hit equals slope, okay, and then in this little call out window, it's telling us what it wants for that formula. So it says I want the known y's, and then it wants the known x's. So the known y values are going to be the natural log of KSPs. Then we hit comma, and now it's on to the known x's, and the known x's are 1 over t. So we close the parentheses, hit enter, and there we go. There's the slope. Okay. They also have an intercept, and if you guessed we type equals intercept, you should pat yourself on the back. We open parentheses, put in the known y values, comma, known x values, close parentheses, and there you go. Okay. The last little bit, we want to calculate delta H and delta S based on that. So delta H, if you look at the formulas at the very front of the lab, you can discern that delta H is equal to R. So we'll type in 8.314 times the slope. We'll hit enter, and we've got to put a negative in there. It is actually the negative of what I just said. All right, so the units on this are, it's 34,000 joules per mole. And delta S then is going to be equal to that 8.314 times the intercept. And this is a positive value, okay? So for delta H and delta S, given the data that I made up, I'm getting 34 kilojoules and 137 joules per mole Kelvin. Okay, so now let's think about making a graph, because making a graph with data is always a good thing to know how to do. And I'm going to go ahead and select the natural log of KSP, and I'm going to select 1 over t. And then we'll go up to the top and we'll hit insert, and we want to insert a certain type of chart. We want to insert a scatter plot or a scatter chart. And I'm just going to put in the dots. Okay. Okay, so now we made the graph. Let's go ahead and right click on this to make sure that we've got our X data and our Y data in the right place. And we're in series 1. Let's hit edit. Drag this over so you can see what I did. Select series 1, edit, and now it asks for X values. I always recommend highlighting this and then hit delete so that you don't have goofiness. I've seen a lot of goofiness with this Excel interface. And we want to select our 1 over t values as the X values. Then let's go ahead and do the same with Y. So we're deleting the values that are in there, and we're putting in the new natural log of KSP values. And then we hit OK, and OK again. And if we didn't like the way it looked, like I can see that we've got a graph there, but none of the data is below 2.5. So let's just go ahead and make that 2.5. So I click on the axis, and then you guys can't see it, but something shows up on the right-hand side of my screen. And I can go ahead and adjust that to have a minimum of 2.5. Okay, so now let's suppose you wanted to add a trend line directly to the graph. the thing to do is to right click on the data, and there one of the options that comes up will be to add trend line. My add trend line stuff is showing up way at the right hand side of the screen. I'm going to adjust my Excel to show you that. Okay. So now I have all of these trend line options, and what I want to do is select linear. I also want to have it display the equation on the chart so that it tells me what it's doing. Okay, so it has now calculated a best fit line, and the slope and the intercept match with the things that I had done before. Okay, so if I wanted to turn this graph in, then I would make a title, make some x-axis labels down here, make some y-axis labels. I'd probably get rid of the grid lines, because who needs grid lines? That just makes it, just distracts from the data. So something like that, okay? You'd want to pretty it up a little bit before turning it in, I think, but this looks pretty good. Okay, so the bottom line is we have calculated a delta H parameter based on our data, and we've calculated a delta S parameter. And hopefully we've learned how to do some simple programming and some simple calculations in Microsoft Excel. Thank you very much.